Hey geometry students, we're going to continue our study of finding area by next looking at a shape called the trapezoid. Now we're not going to fully do this problem, but it's just going to be for a quick visual. We've seen that when we're finding area of certain shapes, sometimes we have what's called a composite shape. And so for this one, for instance, what our background is, we could find the area of this rectangle, right? We could find the area of this triangle, the area of this triangle, as well as the area of this secondary rectangle. And we're not going to formally solve it. I've taken away some of the angle measures and some of the extra sides just so we could kind of see the visual better. But what we have so far with our tools, we would have to find all of these separate areas. However, with the area of a trapezoid, it's going to be viewing this as one whole shape. And so we have the ability to then do this in just two shapes rather than in three. So that's kind of the value of trapezoids, is being able to view a shape not solely just as like three separate shapes. Additionally, sometimes we don't have, like, for instance, this pink side and this green side. Sometimes we don't have all those measurements broken down. There's also the assumption that we know how long, the sides of the triangles are, like this side as well as this side, compared to the middle piece here. So we're kind of assuming that we have a lot of measurements, and sometimes we don't always have those. So that's another reason why this new area formula is going to be useful. So we are going to first look at the area formula of a trapezoid. Apologies, this is supposed to be a symbol right here to show that these lines are parallel. They're the little parallel arrows, so to speak, but they kind of got moved. So we're going to look at how to find the area of a trapezoid, and I've got a quick video to show you guys where the formula comes from. I'm going to write out the formula here so we can see it. Area is, we call this base 1. Base 1 is just kind of this top piece, and base 2 is going to be this blue piece. The two bases, notice, are parallel, and that's coming from our first chapter where we learned about symbols. So you take your two bases and you add them together. You multiply by the height, and so I'll kind of color code those there. I'm going to make the height pink. Remember, for our height, we have to go straight down and make a right angle with our base or our bottom. Right now, I've got the blue as kind of the traditional base. And then we also have to multiply by 1/2. So sometimes I'll typically write it like this, like times height divided by 2. You might see them in different ways. So some people prefer one to the other. You also could write it as 1/2 times base 1 plus base 2 times height, right? There's a lot of different ways you can write them. The order of the 3 multiplications, you can do them in any order. So I'm going to show you a brief video that kind of gives you a little mini proof for why this works rather than just accepting the formula.
Hello and welcome to the Maths Doctor. In this video we're looking at how to find the formula for the area of a trapezium.
They're calling this a trapezium. It's just a more generic term for a trapezoid. Notice instead of base 1 and base 2, they're calling those A and B.
So here you can see we have a trapezium, and a trapezium is basically a four-sided shape, so it's a quadrilateral with one pair of parallel sides. And in this case the parallel sides we've labelled A is that top one and B is the bottom one. Now the only other letter that we use is H, that is the perpendicular height. Now it's not the sloped height, it has to be the perpendicular height of the trapezium. Now just imagine that we were able to slice our trapezium in half. So we're going to cut it in half with a pair of scissors along that line there. Now we're also going to do something else. We're going to put a little hinge at that point there. So just imagine we can flip this whole top half of our trapezium that we've just sliced along this line, and we're going to flip it, rotate it on this hinge, on this centre of rotation if you like. So we can do that by moving this slider, and there you go, we're just flipping our top half of our trapezium all the way around until thud, it hits the bottom, and now we actually have a parallelogram. So if you just look what happened to length A at the top there, so here's our length A, it's actually now moving all the way to the bottom down here. Just watch where length A goes, so it's actually going all the way to the bottom, so I'm going to move it down here. Now, next I'm going to take this little bit at the end away, and I'm going to move it all the way to the other end, and it's going to slot perfectly in place there. So now we actually have a rectangle. We can still see where our top half of the trapezium has fallen into, but basically we have a rectangle with the length is A at B, and our new height is half.
And when they say A add B, that's just a different way of saying A plus B.
Of H. So we can put half of H there, and everyone knows how to find the area of a rectangle. It's just length times width.
So you can then see that we have base 1 plus base 2 times height times 1/2. So that's where this whole component is coming from. So I will include that video as well with our notes. You can go back and rewatch that if you wish. We're going to now do a couple practice problems just to apply this formula and just feel comfortable. So the first one's just going to be finding the area of trapezoid, or as they called it, a trapezium is another term for it, STPM. That's just a name using the letters going in a circle. And so they are also indicating which sides are parallel. They're indicating that these two, our two bases, are parallel. That allows us to verify that those are the two bases for sure. We're only allowed to do this when we have that pair of parallel sides. So I'm going to write out my formula, base 1 plus base 2. I'm just going to do like times height times 1/2, like all three of those just multiplied together. And I'm going to kind of color code. So my two bases, I'm going to circle them in purple. So I'm going to say, okay, that's a 16 plus a 6. Remember, my height has to make a right angle with the base. It has to be perpendicular, times a 6 for my height, and then the 1/2 is just always 1/2. I personally find it helps me to first do half times 6, because I know half of 6 is going to be a 3. I find it helps me just to do that quick multiplication, especially if I've got an even number. That makes it a little bit easier. And then I've got a 16 plus a 6 that's going to simplify to a 22. 22 times 3, that's going to be a 66. And we don't have units, so I'm just going to do units squared. You can write out the word units, or you can just put a U for units if you prefer. Okay, so that's one example as well as the formula. Here's a practice problem. Go ahead and find the area of the secondary trapezoid. I'll leave the first one up, and unpause when you're ready to do a quick verification. Okay, I've color-coded it out. Your final answer is 2.6 square inches. Remember, for area, we do want to use that as our units. One thing that helped me simplify this a little bit faster was doing 2 times a half. 2 halves make a whole, and rewriting that here. And then it was just a real simple thing of anything times 1 is itself. Okay, so those are 2 examples. And then I'm actually going to skip. I'm going to skip past this number 2. If you're wanting a more challenging problem that involves some of the topics from our last chapter, like special right triangles, trig, all that stuff, I'll come back to this one at the end for a quick challenge problem. So let's skip to number 3 and 4. These, I think, are the more critical ones to make sure we understand. These are what I call going backwards. And this is where I'm going to tell you certain details and ask you to kind of backtrack and find other information. So I'm going to just draw like a random trapezoid. I'm going to mark that these sides are parallel. Tells me one base is 10 and another base is 15. Tells me we're looking for the height, but we already know the area. So this is what I call a working backwards. It's where you're given the area rather than just kind of plugging and chugging, and you're asked to go backtrack and find a detail. So my typical strategy with this is I just kind of fill everything in I know. So if I know the area is 50, I'm going to fill that in. right? That's coming from, I'm just going to grab a quick color, 50, 50. And then my two bases are 10 and 15. I'm going to fill those in. Okay. And I don't know the height. I'm looking for the height. And then I do know I'm going to do times a half. Okay, I'm going to simplify this to a 25 times height times 1/2. Now the other thing is I can multiply numbers in whatever order, right? Like 2 times 3 times 5 is the same as 2 times 5 times 3, right? That's like the commutative concept that I can multiply in either order. So what I'm going to do is I'm going to flip-flop these two. I'm going to do 25 times 1/2 times height, because I can do 25 times a half. 25 times a half, I'm going to kind of put my new line of work on this side. That's going to make my equation 12.5 h, right? 2 12.5, so we'll make 25. And then from here, if I want to undo times 12.5, I just have to do a quick division. And so h is going to be equal to whatever 50 divided by 12.5 is. I'm going to do that real quick on my calculator just to verify. Looks like my height is actually equal to 4 centimeters. It looks like that was the original units that were mentioned with centimeters. So it actually doesn't seem like it's going to be a nice clean number, but it does end up being 1. If you want to double check, a great way to double check and verify is to take your 4, your bases, and the 1/2 and plug it all in and see if it multiplies to be 50. That's a great double check. Right, so if I did want to verify, I would just plug everything in, base 1 plus base 2 times height of 4 times 1/2, right? I can tell here that that's going to become a 25, and that's going to become half of 4 is 2, and 2 25s does in fact make 50. So plugging it all in is a great verification. Okay, and then we're going to do this one. This one is a little bit different with what clues we've got. In this case, I have the area. I do actually have a height. I'm going to draw my height here. It's 3. One of the bases is 5, and the other one we don't know. I'm going to call that like maybe B for base. So when I fill in everything, this one's going to be a little bit different, right? My height is 3, and then I've got my 1/2. Oops, sorry. I'm like filling it in rather than writing the actual formula. So I'm just going to call this 5 plus B for base times 3 times 1/2. So this one's going to be a little bit different. Go ahead and from here, think through what the solving process would be and try it out on your own. Unpause when you're ready to check the solving process. So this is definitely a step up from the last problem. Just to go over the answer, my first step is I did in purple that multiplication to get 1.5. And then to get rid of that, because I want to try and get as isolated to my B as possible. I want to get rid of anything I can. To get rid of that 1.5, I divided by 1.5 on both sides to undo that multiplication. That left me what was in parentheses, the 5 plus B, right, is equal to the 16. But at this point, because there's nothing else, I don't really need those parentheses. Right? Before I had to keep them to indicate you had to add those together before multiplying by 1.5, but once I take that away, I don't really need the parentheses anymore. And then just undoing the adding 5 by subtracting 5, and you get 11. The units are centimeters. Okay, so these are definitely a little bit trickier, right? There's a bit of algebra involved or kind of reversing steps in your head. Some students don't really formally write out this full process, but they kind of like show the undoing process. Like they'll kind of take the area of 50 and they'll kind of show their steps. Like they'll show that they take 50 and they divide by a certain number as they're trying to isolate the missing variable. So your work and reasoning may look a little bit differently, but as long as you're showing a process and showing steps to get there with your numbers, that's the biggest thing I need to follow your thinking. If you did want to go back and try this challenge problem, I'm going to pause and work it out, and then I'm going to unpause with the key. So this one is definitely a pretty tricky problem. I did color code my steps. The first stuff I did in red, second stuff I did in blue. Both of these were 30, 60, 90s once you drop the heights. And then from then using your reasoning, you can get all of these lanes using tick marks as well. Plugged it in, showed my simplification. Notice the number in front is a 36 times a 6 times a 1/2. You can really treat it like 36 times 6x times 1/2 and kind of move them around. That's it for today.